bisectors, and now we're going to talk about angle bisectors. So if you remember, perpendicular bisectors intersected the midpoint of a segment at a 90-degree angle and met at a point of concurrency called the circumcenter. Today, angle bisectors are going to intersect the three angles. They're going to bisect the angles, the triangle, so that the measure will be equal on both sides of the bisector, and they will intersect at a point of concurrency called the incenter. So we're going to go through these problems from the other day. AD bisects B. AC, we've done problems like this before in chapter 1. If I tell you that they bisect, you can set them equal to each other and solve, and you get that the answer is 20. Next problem, you should be able to solve this. Answer is positive or negative 5. And the legs of a triangle, 15 feet and 20 feet, find the hypotenuse. 15 squared plus 20 squared equals the answer. Add them all up, you get 625. The square root of 625 is 25. Okay, so we're going to refer back to this. Remember, an angle bisector is a ray that divides an angle into two congruent adjacent angles. So Q, angle QPS is congruent to angle SPR. And if you also remember that the distance from any point to a line is the length of the perpendicular segment from the point to the line, actually from the point to here. So QS and SR are going to be congruent because this point is equidistant from ray PQ and from ray PR. So we have two theorems. Sound recording, so we're going to have to break this into pieces. We now have two theorems that we're going to learn about. The first one is the angle bisector theorem. And this basically says if a point is on the bisector of an angle, so this is AD is the bisector, then it's equidistant from the two sides of the angle. That would be a side AB and side AC. Remember that the shortest distance between a point and a line is through the perpendicular segment that connects the two. So that's why you always need to see this right angle symbol there. The converse of the angle bisector says that if I have a point that's in the interior of an angle and it's equidistant from both sides of the angle, then it lies on the perpendicular bisector. So D, point D, is on the perpendicular bisector because it intersects AB and AC. You could draw a perpendicular segment from D to AB and AC, and that segment is congruent. So now let's see how we can actually use this. So now let's look at how we would use some of these, angle bisector theorems. So obviously, we have example number 1 here, and we can see in this that the distance from J to G is 7. The distance from J to H is the same, it's 7. Both of these intersect the side of the angle at a 90-degree angle. This must be the angle bisector, therefore this must also be 42 degrees. And that's marked there. Then we have a problem about a soccer, the goalie is positioned to the ball and the goalpost form congruent angles as shown. So what they want you to get is that the goalie will have just as far to go to the left as he will to go to the right. So basically we've created congruent angles, are marked there, and this is going to create an angle bisector in real life. And there is the answer there to that. Also, we can use algebra to solve some problems. They ask for what value would x be true to show that P lies on the angle bisector. So basically, since P needs to be equidistant from B to C, we see that both segments there meet at 90-degree angles. We need x plus 3 to be equal to 2x minus 1. When we solve, we get 4. And let's go through some practice on these. You can freeze these on the video if you don't want to watch me. But basically, we can see here in this first one, this AP is an angle bisector. It intersects at point P. The segments have 90-degree angles, so they're perpendicular. The angles inside are the same. That means these segments are going to be congruent, and x is going to be 15. I want to reset this so it's back saved for class. In the second exercise, it is hard to tell what they're talking about there, but it says degrees, so they're talking about the angles. They're talking about angle BPA and angle APC. They both are equal. They're both angle bisectors there. They're both sides of the angle bisector. AP is the angle bisector. You can see that because angle C and angle B are both marked as 90-degree angles, and the length of PB is congruent to PC. So 5 equals x minus 6. That should be plus 5. I add 6 to both sides, and I get x equals 11. And you can see that that's the answer. In guided practice, once again, you know that these are going to be congruent because A is clearly intersected by AP. And since these P is going to be equidistant, since it's on the bisector from B and C, so 5x equals 6x minus 5. Subtract 6x, you get negative x equals negative 5, so x equals 5. Reset it. And another guided example. Another guided practice. Do you have enough information to conclude that QS bisects, even though they are marked congruent? This doesn't show, and this doesn't even look like it's a 90-degree angle. So therefore, you do not have enough information because you cannot establish that SR is perpendicular to QR, nor that SP is perpendicular to QP. They don't necessarily go through the opposite side at a 90-degree angle, making a right angle. So I'd like the arrows to continue on like that. Where they meet is a point of concurrency. It's called the incenter. And the incenter is equidistance from each of the sides of the triangle. Now realize the angle bisector does not get, the concurrency of the angle bisector of a triangle does not give you that the point of intersection is called the incenter. It just tells you that there is a point of concurrency. It is a point where they meet. And then if you wanted to know was the incenter, for instance, if you were using it in a proof, you would have to say that P is the incenter after you proved that that's where the angle bisectors met, because that is the name, that's definition of an incenter. So an incenter would also allow you to inscribe a circle, as you see here. Inscribe a circle inside of a triangle. Whereas yesterday or the day before when we had the last lesson, maybe it was Friday, the circumcenter, which was the point of concurrency of the perpendicular bisectors, meant that the triangle was circumscribed or inside of the circle. So that may help you remember a little bit. Incenter, the circle is inside the triangle. Circumcenter, the triangle is inside the triangle, would be inside of a circle, and that's called circumscribed. Okay? So we can use this information also to find lengths. So in the diagram, N is the incenter of triangle ABC. They want us to find ND. So all of these blue lines, I should make them blue, are all going to be equal because the concurrency theorem tells us that the incenter is equidistant from the sides. We see we make a number of triangles here. So this is 20, this is 16, this is a right triangle. So we can use the Pythagorean Theorem, which tells us that 16 squared plus b squared equals 20 squared. I'm going to use my calculator. So 16 times 16 is 256 plus b squared equals, that's 20 squared is 400. 400 minus 256 is 144. So b squared is 144. That means that b is equal to 12. Even though mathematically you could have negative 12, you cannot have negative 12 as your answer for the length of a segment of a triangle because we do not have negative length. Length distance always has to be displayed as a positive number. And there they take you through that Pythagorean theorem. Now they say, what if, let's do that same problem again, but we're going to use BF. And we're going to say that that's 12, and we're going to say that BN is 13. So different problems, different numbers, 12 squared, which is 144, plus b squared equals 13 squared. You can plug it into your calculator, but I happen to know it's 169. If I subtract 144 from both sides, I get 25. And b has to be equal to 5. Once again, it has to be a positive number. So I went ahead and did that one. I just like to pull it away and see that I was right. Yay! So exciting. Okay. And we have the daily homework quiz. So for this problem, you can see we are finding the degrees here, these angle measures. We can tell that they must be equal, they must be congruent, because we have an angle bisector. We know it's an angle bisector because these are marked as congruent and the intersection is a 90-degree angle. So I get 4 equals x minus 8. Add 8 to both sides, and I get x equals 12. Yay! Okay, next one. I know that this has to be 90 degrees because this is an angle bisector. These angles are equal. So this is an angle bisector. And this here, this segment and this segment are congruent in length. So they must intersect the sides at 90-degree angles. So 90 has to equal 4x plus 10. Subtract 10 from both sides, I get 80 equals 4x. So x equals 20. Let's see if I'm right. It's late at night. On a Saturday night, I'm right. Hooray! Next problem. Point D is the incenter. So that means that AD, BD, and CD are all going to be congruent. They want me to find DB. I have enough information here to use this triangle. So 24 squared, I don't know how much I like that color. I like writing in highlighter sometimes. 24 squared plus b squared equals 26 squared. So 24 squared is 576 plus b squared equals 26 squared is, I believe, 676, but let's see. It is 676. When I subtract 576 from 676, I get b squared is 100. That means that b must be equal to 10. Once again, can't be negative 10. Can be mathematically, but not when we're talking about a geometry real-world application, because distance is always positive. And that brings us to our homework. So you can go through, look at the problems. I'm going to be able to erase those in class tomorrow to show you the answers. And I'm very excited. Hopefully the sound recorded. I've been doing this, breaking this up a few minutes at a time, and we'll see how this video works out. Thanks for watching.